Hello everyone. My name is Harsh Nagrani, and today we'll be understanding the topic binary search algorithm. I was thinking to first cover the concepts of the algorithm and then jump to some lead code and CSES problems. Mainly in this topic, we'll be covering mainly Striver's sheet and some CSES problems that I feel is good for the interviews. We will mainly focusing on the interview perspective, what mainly questions asked in interview. So yeah, let's just look at the algorithm first. Before the algorithm, we have some rules for binary search. So we can quickly cover the rules. So the first rule for binary search is it is a monotonic function. So now what is a monotonic function? A monotonic function is, let's say you have a set of elements in an array. So let's say we have an array. Now for a particular condition, if all the elements are true in that array in a continuous manner, important thing is they should be either true or false in a continuous manner to make it a monotonic function. So as you can see in the first example, we have an array, and for a condition or for any condition, the elements are true for that condition. So we have true, 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 true. So these true are in a continuous manner, so they are monotonic. Again, in the next example, we can see we have an array where for the first four elements are true for a particular condition and the next four elements are false for that condition. So this set of array is a monotonic function, and the next set of array is a monotonic function. But here, as you can see, we have true, false, true, false. So this is not a monotonic function because first we have true, then we have false, then again we have true. So for this particular array, it is not a monotonic function. So binary search cannot be applied in this particular array, or in this particular set of array. So while solving any binary search question, or while thinking of binary search as an approach, we have to see that it should be in a monotonic series, like in a continuous series, like that particular condition should be either true or a false for a continuous series. Then only we can think of, okay, we can apply binary search in this particular question. Okay, another rule for binary search is that the array should be sorted. Okay, so we cannot apply in a tricky way. We have also some other concepts as well where pivot element comes in. We'll see that later. But the main thing is the array should be sorted. So before going to binary search, we'll just have a look at what is linear search. So linear search is basically we have a set of elements and then we have a target element. Let's say we have target as 7. We have to find 7. So what we'll do, we'll iterate over the array and we'll go and check each element and see whether that element is a target element or not. And then if we get the target element, then we'll simply return the index or yes or no, whatever we have been asked to tell. And the time complexity that it takes is O of n. Okay, so it takes linear time complexity since we are traversing each and every element to check whether it's the target element or not. Okay, so do we have any optimized approach to do the same task? Yes, we do have, and that is binary search, which reduces the time complexity of from O of n to O of log n. Okay, so now we'll see how we can implement binary search as an algorithm. So let's say we have a sorted array and the array is 1 2 3 4 5, and let's say we have got target element as 5. Okay, so the first step would be to define two pointers. The first will be the start pointer, which will be pointed at 0th index, and the second pointer will be the end pointer. In this case we have taken I and j. You can take any element, you can take any variable. So then we have end pointer, which will be pointed at the last element of the array. Okay, and then we'll run a while loop. Okay, while start is less than equal to end, we have to iterate it over a loop where we'll find the mid element. Okay, so now what does this mid element do? We'll come to that. So in this particular case we have 0 1 2 3 and 4. So the mid element is 2. So our mid is 2, our start or I is 0 and our j is 4. Okay, now we have to compare that our mid element is equal to the target element. Is our mid element equal to the target element? In this particular case, no. We are, because our target element is 5 and our mid element is 3. So now, since our mid element is less than the target element, we'll shift the ith pointer from mid to mid plus 1. Because why? Because because just imagine, if 3 is less than 5, then of course 2 and 1 will also be less than 5. So there is no point in searching the left part of the array. We can directly move to the right part of the array and search whether we have the target element or not. Okay, so that's why we observed that okay, our mid element is less than the target element. So what do? We bring our start pointer to the very next pointer of the mid element. So we brought I from 0 to mid plus 1. So now I will be pointed at 3. Okay, and then we'll run this loop till we get the target element. Okay, so in this particular case we'll be having two approaches. In the first approach, either we'll get the target element or else we won't get the target element. In this case, if we won't get the target element, then we'll simply return -1 when we don't get the target element. Okay, so let's just look at the code. And for the code, we'll be doing lead code problem, which is a easy problem, easy level problem, and which is based on the classic binary search approach. So let's look at the problem. So the problem says, given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return it, otherwise -1. So as I told you, we'll be having two approaches. Either we'll get the target or we won't get the target. So when we don't get the target, we'll simply return -1. Okay, and we'll just see one test case, one example, and then we'll move. So as you can see, the array is in sorted format. We have the target element as 9 and the output is 4. Why 4? Because 9 is present at the fourth index. So let's just try to write the code for this and we'll see whether it works or not. So first, as I told you, we'll define the start and the end pointer. And then we'll run a while loop. Okay, and then we'll check. So the first condition will be, we'll check if our mid element is equal to the target element of or not. So let's just look if this is good enough or not. Let's just run it. Okay, so this is accepted. Let's just submit it.